Hello. I'm gonna show you there is no rectangle on hyperbolic plane. So this white part, white circle right here is my hyperbolic plane. So we're gonna go through how to construct some basics element on hyperbolic plane. And then from that, we're gonna go to the theorem that I just told you earlier. There is no rectangle on hyperbolic plane. So let's construct a hyperbolic line first. So here is this special app. So you're gonna click on here, it say hyperbolic line. So collect 2 points. So I'm gonna select this point right here. I'm gonna select this point right here. Yes, CD. And then, so this one create a line right here. So this one look like straight. So it's like normal, like we see in Euclidean. However, if I do the point right here, I do the point right here, then you see this line is not like the line we used to see. There's a curve, but however, this is a line on hyperbolic plane. I can construct a triangle on here as well by create a segment. So I have right here. So for example, I have this is my first segment like this, and then I have EF. I have segment. The next one would be FG, and then the next segment would be EG right here. So I have the triangle. And in triangle in Euclidean geometry, the sum of all angle equal to 90 degree, 180 degree, but this one is not. So let's measure the angle right here. So I'm gonna choose to measure the angle. So I'm gonna choose measure angle EGF right there. Oh, wrong one, wrong direction. FGE right here. So I'm gonna measure the inside angle 83 degree, right? And then I'm gonna measure angle EFG. So that's one will be 42 degree. And the angle GEF. You see that? So you add the three number is not equal to 180. So that is the first thing that you see in Euclidean and hyperbolic plane. The sum of angles in the triangle not the same, right? Euclidean 180, the sum of 180, but hyperbolic plane, this one you can see that less than 180. You can create as many triangles you want on this plane. You will see the sum of the triangle will less than 180. So that's the first one. So now I'm gonna show you the next part right here. So I'm gonna create a perpendicular bisector CD right here. So let me show you right here. This one you're gonna choose from here. You choose hyperbolic perpendicular bisector of that segment CD right here. You click on this, and then this one is perpendicular bisector. So perpendicular, that means the angle have to be 90 degrees right here, right? So we're gonna measure that. However, you see bisector, that means divide in two. You see, let me give this a name so that we can have something to talk about. The intersection of this curve, this line, and this line right here, that would be E, right? So you see that CE and DE, they're not equal. However, it's equal because a bisector is better equal in here, right? And then I'm gonna measure this part right here for you to see the angle. So I'm gonna measure angle DE and this one right here. And you see angle right here, 90 degree. And you see that, so let me move this so that you can see. So it have the symbol, wrong one, I have to move it right here. You see the perpendicular symbol and then the angle 90 degrees. So this angle FED 90 degrees. So same thing with the other three angles should be 90 degrees as well. If you measure, you see that. And so now I'm gonna create a segment, a parallel line with CD right here, okay? So I'm gonna do right here, I go to parallel with common perpendicular. So the instructions say you select a line perpendicular and the point out on the first line. So I'm gonna select this line right here. I want to parallel to, and this one is the common perpendicular. That means both lines perpendicular to this line EF, and I'm gonna choose the point right here. Then I will have the two. So let me give this a name. Okay, so line GH and line CD is parallel, and they both perpendicular to line EF. So let me measure the angle again. You will see that angle with the 90 degrees as well. Okay, right here, you see 90 degree. Yeah, you see that? You see the tiny little perpendicular right here. Kind of hard to see. It's like a little bit right here. You can see that part right there. So this angle right here, 90 degree. Okay. Now let me move this one over here so it's out the way so that we can see. You see a tiny little triangle, right angle right there. Okay. So now I'm gonna create a quadrilateral. So I have GH E right here. So these two angles are 90 degree already. I want to create another 90 degree angle right here. See, and then I have three angles, right? So I'm gonna go now this way right here. I'm gonna choose the part. I'm gonna choose the part right here. So I want a line that perpendicular with line GH and pass through G, right? So that's what I'm gonna choose this line, and I'm gonna choose line G. So I'm gonna pass right here. So the intersection, so let me give the name right here. Yes, oops, wrong one. The intersection, so I want this line and then this line, by that give me point I. So that quadrilateral IGHE, this one right here, I have three right angles. So angle E 90 degree, angle H 90 degree, and angle G also 90 degree. Let me measure this for you. So I think I go this way. Oh, wrong way again. I go this way, this way, this way, like that. So I have 90 degrees right there. Okay. So you see the three angle are right angle right there, right? And then, so let me summarize that again. So I have line G8 parallel with line CD, right? And the FE perpendicular D2 and angle G here 90 degrees. So in Euclidean geometry, this angle should be 90 degrees. However, this one is, it won't be. So let me measure it for you to see right here. So I'm gonna measure this. So I have to be clockwise right here. Yes, right there, 54 degrees. So no matter what you do, there is no rectangle in hyperbolic plane. It's always the sum of all the four angles right here is always less than 360. So you have these three together, 270, you add it together, no matter what you do, it doesn't have that. Remember, we have from beginning, the sum of three angle in the triangle, it's less than 190 or 180. So therefore on the quadrilateral, it will less than 360. So no matter what you do, you cannot have four right angle in a quadrilateral. So therefore no rectangle.